Okay, we're going to have a look at a composite great circle problem now. Now, composite great circle is where you travel between two places, obviously by the shortest route, but there's a restriction on your latitude, so you have a limiting latitude. Often this applies where you're travelling in a certain zone, maybe summer, tropical, winter zone, and you reach a latitude and you can't go any higher than that because you'll go into another zone which will probably be no good because of the draft of your vessel. So that's one of the reasons why you would have a limiting latitude. So you would sail along on an east-west route until you used up sufficient fuel and stores, etc., so that your draft would change and you could go into the next zone. So with the limiting latitude, you'll know your initial position, waypoint A, you'll know your final position, waypoint B, and you'll know your limiting latitude. So V1 and V2 is the same latitude, and that would be your limiting latitude. So in between these two here, you'd be going on an east-west course. Okay. So with composite great circle, then your voyage is in three parts. So you've got right-angled spherical triangles. In your first part, PAV1, you've got your initial course A and your distance AV1. In number 2, you've got a course of 090270 and a distance V1 to V2. And part 3, your final course B, or reciprocal of B, is your final course, and distance BV2. You can only calculate this second one after you've calculated 1 and 3. That's because you need the D long values for these two to find the D long for V1 to V2 to get your departure is D long cos lat, where departure is your distance. So you don't know this D long, so you'd need to find these two values before you can find this third one. So solve that spherical triangle, that one. Once you've got those two done, you can then subtract their D longs from the whole D long for the problem between the two, and that would give you this value in the middle. So you'd know the total D long between them, but you'd subtract these two values from it to give you the D long for this central one. So let's have a look at one here. We've got waypoint A, 3739 north, 12306 west. Waypoint B, 3451 north, 13955 east. Okay, and we've got a limiting latitude of 40 degrees north. So P1, P to V1, P to V2, the 40 degrees applies there. So we know the values of PB, PV2, PV1 and PA. PA is 90 degrees minus our latitude, PB is 90 degrees minus latitude B, and P1, V1 is 90 degrees minus our limiting latitude, which is 40 degrees. So P1 and PV1 and PV2 would be 50 degrees. Okay, so we know all those four values. And we know with Napier's rule, sine mid parts equals tangent of adjacent and cosine of opposite. We've gone through those in a previous video, so we know those values. So we would find our initial course, and of course with that would be northwest. We're going from A to B. So we'd find distance AV1. We'd find P, which is APV1. With that value of P, we would add that value calculated to the longitude at waypoint A, and that would give us our longitude at PV1. Okay. Then we'd find our final course B, as we've looked at previous examples to find that, or the reciprocal of B. Obviously this will be southwest. We'd find our final distance BV2, and then we'd find P, B, P, V2. So initially we could find AV1 and we could find A, our initial course. Then we found the D long here. We did exactly the same for this other triangle. We could find BV2, the distance. We could find our reciprocal of our final course, and we could find this D long. So we've found both those D long values. Then after we've got those, we calculate the difference between the longitudes at V1 and V2. Okay, and the distance v1 to v2, the departure, is going to be using the formula d long times cosine of latitude. Now, a common mistake students make here, they would use the value PV, cosine of PV. Well, it isn't. It's the cosine, of course, of 40 degrees, not 50 degrees. So always make sure you use the latitude. Okay, so your total distance is going to be AV1 plus BV2 plus V1 to V2. Okay, now just incidentally, if you're struggling a bit working out when you're going from west to east with or east to west with longitudes, if you imagine you're looking down now at the North Pole there, we've got north, south, west and east. So if we're looking down, we've got west and east here. What's happening here is we're going from 123 degrees west, we're going this way right round to 139 east. So you can see that's the way we're going, and you can see we're going in a westerly direction. Okay, so hopefully you can see that. So our initial course is going to be, of course, northwest, and our final course is going to be southwest. So you can see we're going either side of the 180 mark. That's our meridian through the pole, and that's 0 there at Greenwich, all the way around to 180. So that's westerly direction. We're going westerly all the way around. So that's perhaps a way you can see that if you're unsure of how you get those values. So that's how we would solve the composite problem. But crucially, you have to find the two spherical triangles either side of the central one before you can find that final distance.